about odd and even functions. It just fits perfectly with these transformations. Some functions, when you flip them about the y-axis, retain the same graph. And then we call it even. So flipping about the y-axis leaves the graph alone, or you obtain the same graph. And as an equation, the flipped function about the y-axis is f of negative x. And that's supposed to be the same thing as f of x. So here's your equation to check whether a function does this. The graph, when you flip it about the y-axis, is the same. Example, the standard prototype example, x squared. But then you can also do x to the 4th, x to the 6th, every even power of x. You can multiply it by constants. You can add constants. You can add, well, two even functions together. And you get another even function. And the graph, in another word, has mirror symmetry. With the mirror axis being the y-axis. Okay, and the very last item, odd functions are those where the graph stays the same when you rotate it by 180 degrees about the origin. And as an equation, that rotated function has this formula. That's supposed to be the same thing as f of x. So that's the way to check whether a given function is odd or has this rotational symmetry. Classical example, the function y is x, or x cubed, or x to the 5th, all the odd powers of x. Why does that work? Let's check x cubed. Negative, use negative x as input for the cube function, and you check, yes, it's the same as x cubed. Check. Again, you can multiply these by constants. You can add them together or subtract them. I meant x to the 5th. And you can even multiply two even functions, get an even function. You can multiply two odd functions, get an odd, get an even function. And you can multiply an even times an odd function and get an odd function. And this is a great little exercise to try it out. Maybe it will come up as a project problem. I could do some examples for this sort of thing in lecture. You think about this particular equation. Why is that true? As an example, take the absolute value function, which is even. You can tell from our graph has mirror symmetry, times x, which is an odd function, and that's an odd function. Okay, enough